Hello everyone, welcome you all to the lecture 5. Today we will be solving these problems. So these problems are include the basic implementation of the loops and conditional statements, and there is some mathematics that required for you solving simple mathematics that will be required for you solving the coding problems. Yeah, let's start with first one, that is a reverse of a number. So you are given first. Let's read the input here. Let's We will be given an input as something like 1 2 3, and we need to give the output as something through 3 2 1. So this is the input and this is an output, and we need to write a program that can do this work. Let's see how we can approach this problem. First of all is I want to uh, teach you that how this number is converted to this number. First I will be expanding this first number, that is 10 1 into 100 plus 2 into 10 plus 3 into 1. So if I can write the these numbers like multiples of 10 in the powers of 10, you can see it would be 10 power 2 plus 2 into 10 power 1 plus 3 into 10 power 0. Likewise, if I can write the extent, this is, so let's wait a minute. So this is for the 1 to 3, right? Similarly, if I write for the 3 to 1, you can observe one thing here. Let's say 3 into 10 power 2 plus 2 into 10 power 1 plus 3 into 10, sorry, not 3, it is like 1 into 10 power 0, right? So when you are shifting, you are only shifting like 3 to the left side. How many places? 2 places. That is 3 shifted to 1 and 2 places. That means initially 3 is having 10 power 0. So when you are shifting to 2 places, it got multiplied with the 10 power 2. So this is a simple observation you can make from this. And yeah, 10 is shifted to one place only. So there is no multiplication of the 10, and after you can see that 1 is shifted to the right. 1 is shifted to the right, and it got decreased when you are going for the right. 10 powers got decreased, right? And for the when you are going for the left, you are multiplying 10, and when you are going to the right side, you are dividing with the 10. So that is the core mathematics and basic mathematics that is mm, happening behind this logic. You are simply doing number by 10, right? So this is how we can visualize that we are simply shifting this 1 to the right side, 3 to the left side. And if you take bigger number, we'll get more idea about this. Let's take this number as 1 2 3 4, and I will be write expanded form like 1000 plus 2 into 100 plus 3 into 10 plus 4 into 1, right? So as it is, if I can write in terms of powers of 10, it is 10 power 3, sorry, it is 10 power 3 plus 2 into 10 power 2 plus 3 into 10 power 1 plus 4 into 10 power 0. As it is, if I can write the reverse of this number, what how it look like if I will reverse this number, it would be 4321, sorry, 4321, right? So if I can write the expanded form of this number, it would be definitely like this one. And 3 into 100 plus 2 into 10 plus 1 into 10 power 0. Yeah, that's look like. And if you can write in terms of powers of 10, it would be looking like this: 3 into 10 power 2 plus 2 into 10 powers 1 plus 1 into 10 power 0. If you can observe here, so you are shifting 4 to the 3 places, is it right? And how many places? 3 places. And you are multiplied, initially 4 has only 10 power 0. So when it got shifted to 3 places, 1 has got multiplied to 10 power 3. And when 2 is shifted to these places, let's I will be writing 1 is shifted here 3 places, right? Wait a minute, I will be writing it very clearly so that you can understand very easily. 1 2 3 4, right? Let's say 4 is shifted to these places and got multiplied with the 10 power 3, right? I will be writing short. Yeah, 10 power 3. 3 is shifted to two places, these two places. That means 3 into 10 power 2. You can see this is how we got result. And 2 is replaced. 2 is shifted to one place, that is 2 into 10 power 1. This is how we got that result. And after that 1 is shifted with 0th places, that means 1 is at the this place. That means that you can see 1 is got at the last. And initially 1 has like 10 power 3 it is. And in this, after reversing, you got the 10 is removed all the powers. In the one you have, there is no powers of 10. How we can do this problem? So there is slight observation that every time we'll be writing here. So what we can do is, every time we are multiplying, let's say this is 1 2 3 4, right? So what we can do is, we are taking 4, we are multiplying 10. So and after that we are adding the remainder. That means we need to add this element 3. So we got 43. So again I am multiplying with 10, plus what is the remainder after 3 2, 432. After that 432 into 10, plus what is the remainder 1, 4321. So let's see how it is started. Initially, every how many times we are multiplied 10? 3 times. And every time we are adding this remainder. Initially, like it would be having, yeah, 4 equal to 4. So first we are having 4 as a, let's say this is an element. We are taking removing 4 and we are taking 4 out from these digits. How we can take this 4? So when you do n modulo 10, you will get 4 as a digit, last digit, right? So with this digit we are forming this first one. And after that, what I'm doing, um yeah, I will be multiplying with 10, and again I will be taking 3, that is 3. So 43, again you can see 43 is multiplied with 10, again taking remainder, that is 2. Again 2 got removed from here, and we are left with 1, that is, so again multiplying 10, that we are left with only last digit, right? So this is 1. You can observe this. What is this numbers are? These are the remainders, right? So how we can find these remainders? Let's say I should have definitely something like here. We will be having 0. So this is a pattern you can observe here, that, so I will be writing here. So initially 0 plus 4, and after that you will be having something like 4 into 10 plus 3, 43 into 10 plus 2, and the next one is 432 into 10 plus 1. You can observe here, every time we are removing that element, number from the sorry, every time we are removing the digit from the number 1 2 3 4 and adding to our answer. So I will be keeping my answer as, initially I will be having answer as 0. What I can do initially, first I will be go take that element, I will be take this element. So I will be do answer into 10 plus, this is remainder, right? So I will be storing my remainder as first. So I got remainder 4. So I will be storing 4. After that, what we have got, answer is equal to 0 into 10, 0 plus 4, which we have got 4. So what is the answer is having? Answer is having 4. Next time what I can do, again I will be do answer into 10 plus I will want to take remainder. So I are already having, I, I will use this remainder, I will be removing from this, and I will be taking remainder as 3. What I can do, I will be add this 3 into my answer. So what I am getting now, answer is already, let's run it out. So answer is having something, what? Answer is already having 4 into 10 plus 3. What is the value? 43. And again we will be do same thing. Again answer into 10 plus remainder. What is the remainder? So we need to, after taking this out, just remove from here also. So So the remainder is 2 now. I remove from here. Yeah, I will be doing 2 here. What I will get? So 43 into 10 plus 2, I will be get like 432. Again, I will be doing same thing. So this is my answer. Answer is equal to 10 plus remainder. What is the remainder? So we are only left with 1 here. So just add this one here and we will get 4321. You can see how the transition is going on. Every time you can definitely see that every time we are um, multiplying 10, multiplying 10, multiplying 10, right? So this is how the simulation is going on. Yeah, this is the problem. So let's write the code for this one. So um, I already taught you that how we can remove the last digit and how we can find the remainder, find the last digit, remove last digit and find the last digit. So it's very basic idea. So what I'm doing is, let's say number is equal to 43 1, right? So I want to reverse this number. Output should be look like 134. So before that, I want to find remainder. How I can find remainder? So I will be do number modulo 10. I will be get this last digit, but I, I have not removed this digit. How I can remove this digit? So I can remove this digit by using like something like number divided by 10. If I do this one, I already told this in the previous lecture. If you are not getting this one, so it's very basic mathematics. You can see. After that, yeah, we know that how to get the last digit and how to remove the last digit, so we are good to go. So until we will be having number as positive, then we will be looping for this number. So what we can do, we can until number is greater than 0, so go on doing this one like get remainder is equal to number and modulo 10. After getting the remainder, remove that element. It means that I should update this in how I can read. So let's say this is a 431. I next iteration I want this one. Next iteration I want this. At last we need to stop here. So yeah. So number is equal to number by 10. So this could be remove the last digit, right? So this is the here we need to write the core logic which is storing our answer. Initially our answer is 0. What I am doing, every time I am multiplying my answer in with the 10. So answer is equal to answer into 10 plus I'm adding remainder also, right? Remember this one. Yeah, this is all about this reverse of a number. So we will be writing code in our ID. I will be using IntelliJ ID. You can use any other online ID also. Then lecture 5. So what I can do is I will be taking n is equal to something 1 2 3 4, and I will be storing answer as 0 while my um, while n is greater than 0, and go on take the last digit like into remainder is equal to what, n modulo 10, and yeah, I want to update my answer is equal to every time I will be multiplying with 10 and I will be adding the remainder, right? So after that I need to update my n here. I will removing last digit, right? So taking remainder. Yeah, this is how the program is look like. What I can do, I will be see out s out answer here. You can see the result. So I will be taking current file here, and let's see what is the output of this code. Yeah, we are got this one like 1 2 3. The output should be 4 3 2 1. We are done with this one. So this is the standard logic, instant mathematics, basic mathematics you can use to solve this problem. And let's move to the second question. Factors of a number. So what is the factors of a number? So factors of a numbers are those number which are multiple of the number and those number which are completely divide the n, right? Let's see what in detail. So the factors are multiples of a number. Factors are multiples of a number divides complete perfectly or completely divides completely. That means when you divide the let's say n is equal to 5 and I am having factor of 1. So when I am doing n modulo, wait a minute, completely, right? I will be writing this. Yeah, this is the definition. So let's take some element. Let's say I'm having number as n and the n is having factor of x is the factor of n. So what is the divide completely? It means that when you modulo with x, it should be give the remainder 0. This is what the divides the completely means. Let's see how we can find factors of a number. So before that, taking one of the example. Let's say I'm taking number as 12, right? So what are the factors of a 12? Like one is a factor of a number 12, and 2 is a factor of a number, 3 is a factor of a number, 4 is a factor of a number, 6 is a factor of a number, and 12 itself is also a factor of a number. You can take any number and you can do something like 12 modulo 2 is equal to 0. You can try out with every element, they will definitely give you as a remainder as 0. So this is what we can call this, they completely divides n. So if I want to find the factors of a number, so at what point I need to stop here? N, right? I need to go until n. For every n, for every I, let's say I is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If I want to find the factors of 12, how I can find? So I'm saying that if the number is completely divides the n, then I would say that number is factor of a number. So this number is divides completely with 12. This is 3, 4, 6, 12. So I don't want this number 5, 9. So they are not factors of a 12. How I can do? If I want to check that the number is completely divides 12 or not, how I can check? So it's very simple. We already discussed that if number modulo I or I will be taking this all elements as I, indicating I. So this numbers, if any number is giving me as a modulo 0, that means this number is completely divides the n, right? So I would definitely print print the I, because that is my factor here. So this is the simple logic. We will be, what we can do is we are simply going from, yeah, wait, I will be write the pseudocode here. Yeah, what I'm doing is, let's taking a number is equal to 12. I need to traverse until this number from the 1. For I is equal to 1, I is less than or equal to number, increment every time. So the logic is that if the number is completely divides, the I is completely divides the number, that means the number is modulo I is giving me remainder 0, then I would say that uh, print the I is the factor of number. Yeah, this is a simple program for the how to find the factors of a number. In future we will see how we can optimize this one also. Let's code it up. I will be commenting it out. So I will be taking int n is equal to 12. I want to find the factors of a 12. For int I is equal to 1, I is less than or equal to 12, I plus plus. If in any case the number is divide the, in any case if I is divides the n completely, that means I would say that is the That is the factor of a number. I will be simply printing I. Let's see. I will be running it on. Yeah, you can see 1, 2, 3, 4, 5, 6, 12. We already saw in our slides. So this is the answer for this factors of 12. You can take any of this. I will be trying with 15. You can definitely see. Yeah, you can see 1, 3, 5. Right. So these are the factors. Yeah. Wait a minute. 15 is also factor itself. Very small correction. If I will be running from 1 to 15, I will be checking that the possible numbers that completely divides the n, and I will be simply printing. So these are the factors of a number. This is the program for factors of a number. Let's move to the how to check number is a prime number or not. So what is the definition of a prime number? So the definition of the prime number is having exactly two factors, right? Having exactly two factors is it is a definition of the prime number. So what are the two factors? The first one is 1 and the second one is number itself, that is n. So there are only two possible factors. Let's say I will be having n is equal to 10. How I can check that the number is having only 10 factors? It's similar to the previous problem. You can see this is very standard, like you know how to find all the factors. So if you can do same thing, that you can find all the factors of the 10. You can count all the factors of 10. Let's say I will be having n is equal to 10. I want to check that 10 is a prime or not. What I can do, I will be traversing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I will be traversing until n, right? To find factors, we already saw that we need to traverse until n. And every time, how I can say that is a factor? We already know that if it is factor, the number is exactly completely dividing the n. That means giving the remainder as 0. Let's say 10 modulo 1 on 10 modulo 2, 10 modulo 3. This is how the iteration is going on. 4, 5, 6, 7, and 8, and so on. So this is how the every time the iteration is going on, and you will see that. So what is the factors of 10? So you can see this is a divisible. 10 modulo 2 is equal to 0, that is 2 into 5. Yes. And you can see 10 modulo 5, it is giving you 0. So this is also factor, this is also factor, and at the last 10 is also a factor itself. How many factors you have found? So the count of factor is 4. So what is the condition of the prime number? It should have exactly two factors, right? Let's take some example for the prime number. Let's say I want to check the 11 is a prime number or not. What I can do is I need to traverse from 1 to, I will be writing here 5, 6, 7, 8, 9, 10, 11. So for every number I will be checking is it a factor or not, for by simply dividing this number. Yeah, 1 is a factor of 11. There is no other factors, you can see. There is no other number that divides 11. So there are only 1 and 11 are the factors of a number. So there are two count of the factors. You can say this is a prime number. So you can use similar logic in as previous question, but you can maintain one count here. What you can do, you can maintain count. You can simply, yeah, sorry. What I can do is I should have factor condition here that number modulo I should be equal to 0, means I will be increase that I have found one factor here, and I will be say that I will be increasing my count one here. Yeah, I will be count plus is equal to 1. I will be declaring count is equal to 0. So what I can check here is if count is, if it any case, when we say that the number is not a prime number, when the count is greater than 2, right? If it any case count is got increased 2, if it is equal to, then we can say it is prime number. But if it any case, if the number is greater, if the number is having factors more than 2, then we can say not a prime. Yeah, this is a simple logic extended version of this previous problem. So We just introduced one count here to count the number of factors, and we can checking that if it is there is a factors, only two factors, then we can say prime number. Let's this is same as code. I want to just modify it. I will be taking as 11, that is prime number. So instead of I will printing, I will be maintaining one count here that will be counting number of factors, eh? So yeah, I will be increasing my count, but I can check if it count is greater than 2, then I will be say that this is not a prime, this is not a prime. Else what I can write here, I can write that yeah, this is prime number, this is prime number. Yeah, this is prime number. Let's run it out. So what would be the output? This is prime number. Let's modify the n, like I will be modifying it 10. Let's see is it giving the right output or not. Yeah, this is not a prime number, it's working well. Let's let's go for the last question, that is GCD and LCM. So first I want to tell you that what is GCD, that is greatest common divisor, right? It's nothing but highest common factor. So how we find the GCD of a two number? I will be having A and I will be having B. So if I ask you to find the GCD of A and B, what you can do? So it's nothing but highest common factor. So it's completely these complete all the questions are complete. The last three questions, like from second two, three, four, are completely based on the factors only, right? So you can use similar logic for the all these questions. Yeah, I will be having A is equal to 12, B is equal to 8, right? What I can do is I want to write factors of the 12. 1, 2, 3, 4, 6, 12 are the factors of a 12. And factors of 8 is 1, 2, 4, 8. So number itself is also a factor. Yeah. So we just leave this one first for a while. So we will go for this with this definition, highest common factor. What is this? Highest common factor. Yeah, write the all the common factors, all the common factors, write all the common factors. That is, 1 is a common factor, 2 is a common factor, 3 is not a common factor, 4 is a common factor. Yeah, we got three common factors. From this we need to find highest, that is 4. Is it very easy to find, right? Yeah, we how we can do this one. Yeah, we can observe one thing is that, let's take some of the other example, like so we all know that how to find factors. Do you think that let's say I will be taking some example which are you used in the logic, like I will be taking A is equal to 16, B is equal to 8. Yeah, you can see factors of 1, 2, 4, 8, 16, right? These are the factors of a 16. 1, 2, 4, 8. Can you see that if I will having something number like more than 9, do you think this is that could be the factors of 9? No, right? 8. So we are only having common factors until the 8. So if you can go after the 8, you cannot find any common factors in between, because 8 is only having last factor is 8. Find them GCD of A and B. So what my concern is that we can traverse from I is equal to 1 to the minimum of A comma B. So you might have get question that why minimum. Let's see. A is equal to 12, B is equal to 6. Let's take 6. What is the factors of 12? 1, 2, 3, 4, 6, 12, right? What are the factors of 6? 1, 2, 3, 6. So the minimum of A and B is, so minimum of A comma B is 6, right? So I'm telling that we need to only traverse until 6. So if you travel after 6, it doesn't give any common factor, because 6 is only having factors itself, which is the highest common, which is the highest factor for the 6. So if you can go after the 6, you can see there is no, you cannot find any common factors. So 6 is also only having common factors as 6 itself. That is only the valid factor. After 6, you cannot find any factor for the 6. So I would definitely say that if we can go until the minimum of a comma b, then we can good to go. We can find all the common factors. Let's see what is the pseudocode for this one. Yeah, it's very simple that we are traversing until like, let's write something like 1, 2, 3, 4, 5, 6. I will be taking a is equal to 6, b is equal to 12, right? And every, for every I, what I am doing is, if every I should be a divided, a modulo I is equal to 0, and b modulo I is equal to 0, then I will be storing GCD, right? GCD of I is equal to I. Let's dry run it out because you will get confused. So I will be having I is equal to 1. What I am doing is 6 modulo 1, and what, 12 modulo 1. Yeah, it's the right, it will be the GCD. So what is the GCD storing? Now GCD is storing 1, it will be giving 0, right? Yeah, we don't want to write this complete thing, so I want just telling, I will be just understanding you that. So yeah, a modulo I, that means 6 modulo 1, 12 modulo 1 definitely give you the 1 is factor for both. So I will be storing 1. So when I will be move for the I is equal to 2, I is equal to 2, then I will check that 6 modulo 2 and 12 modulo 2, are they both are giving equal to 0. You can see 2 3 is a 6, 2 6 are 12. Yeah, this is also a valid answer. So what I'm doing is I will be overwriting the GCD. I will be, now I will be putting 2 here, and when you are going to I is equal to 3, again you will check that 6 modulo 3 is equal to 0, and 12 modulo 3 is equal to 0. Yeah, you can definitely see that this is true, right? So this is also true, this is also true. Then you are modifying it as 3. So when you are going for the I is equal to 4, you can do 6 modulo 4 is equal to 0, and 12 modulo 4 is equal to 0. If this condition is true, both conditions are true, so you can definitely see this is false, but this is true. The complete statement is false. So this is 4 is not a common factor to both. So 4 is a factor for 12, but it's not factor for 6. So we are not doing anything, we are not going inside the if. So we are failing this condition. So let's move for the next condition. Let I is equal to 5. You can see 6 modulo 5 is equal to 0, and 12 modulo 5 is equal to 0. Yeah, none of these conditions are true. We are not going into the if condition. And let's move to the next value, that is I is equal to 6. That is 6 modulo 6 is equal to 0, and what, yeah, or 12 modulo 6 is equal to 0. Both conditions are true, and we are going inside the if, and we are marking it as 6. We are getting GCD of 6 comma 12 as 6. You can see. Yeah, this is how, if you can go after 6, you can see what will happen. 6 modulo 7, it would be giving 6, right? Because at any case, if this 6 modulo, if I will be dividing 6 with any bigger number greater than 6, then I will definitely get 6 only. So that's why we are not having any common factors after 6. So this is how this iteration is going on, and I will be storing this. Yeah, this is all about. And let's discuss about the LCM. What is LCM actually? Yeah, I want to find the LCM of like 6 comma, let's say 4, right? I want to write the multiples of 6. So 6 into 1, next one is 6 into 2 12, 6 into 3 18, 6 into what, 4 is 24. Write the multiples of 4 here. That is 4 into 1 4, 4 2 is 8, 4 3 is 12, 4 4 is 16. So you can find the LCM is least common multiple, least common. So the multiple should be common and it should be least. Let's write the common multiple first, right? So I found 12. So I don't think that there. I think that there might be some other. We don't care about this. There is some x and y common multiples. We don't care about this, right? So we found one of the common multiple. That is this one is a common multiple, right? So this is the LCM of these two number. This is the least common multiple. Why? Because in the, let's say these are not common, these are not common, and this is the first two. We found that this is the first multiple that is common in both. That is only least common multiple. How we can do this one? Let's say, I think you all know this property like GCD of a comma b. GCD of a comma b, LCM of a comma b is equal to a into b. This is a standard mathematics property. You can see proof also. And after that, what we are modifying it. Let's say we know that how to get the GCD of a comma b, right? So it's very simple that what I can do is I will be simply putting GCD as dividing, pushing my GCD to this right hand side. So it will be dividing this a into b, and we can simply find the LCM of a comma b. So let's code it up. Yeah, this is a code for the LCM and GCD and LCM. If you found the GCD, you can simply find the LCM. Yeah, this is all about these four problems for today. So in this next lecture, we will be solving problems on pattern printing. So, so this, if you solve the, you will be solving pattern printing. If you do the problems on the pattern printing, you will be deeply understand the loops and conditional statements. Thank you for watching.